Hello, I am Giulia Pasquale and I'm happy to introduce ConCon-Chi, a concept-context chimera benchmark for personalized vision-language tasks. Recent vision-language models excel at associating textual descriptions with images. These models are not bound to a closed set of classes but can operate on free-form textual descriptions. However, formulating effective descriptions, especially for uncommon, novel, or specific concepts, such that the model returns the expected output, can be very challenging. To this end, recent methods propose to learn the textual representation of a user-specific concept from few images. To represent this challenge, personalized versions of text-to-image retrieval and text-to-image generation have been proposed. The task consists of learning a user-specific concept from few images and perform text-to-image retrieval or text-to-image generation of such concept in a known context. We highlight two key properties that methods for personalized concept learning should have: the capability of learning new meanings and of composing them with known ones. We contribute a benchmark designed to evaluate these capabilities and highlight limitations of the evaluated methods in these terms. Inspired by the Chimera dataset in NLP, we included as concepts chimeric objects, created by the union of two unrelated existing concepts. We also included instances of the object categories composing the chimeras, which are thus visually and semantically similar, and of other common objects to enrich interactions among the considered concepts. After that, we listed down more than 100 contexts and photographed each concept in all the contexts applicable to it. We acquired 4K pictures of more than 1K concept-context combinations, ensuring to represent each concept in many contexts and many concepts in the same context as well. To quantify the importance of attending the concept and the context for correct retrieval, we modeled the concept-context interaction by computing a query embedding as weighted sum of the clip embedding of the context and the clip embedding of the concept training images. By comparing with related datasets, we observed that ConCon-Chi shows the highest performance gap between the peak retrieval performance and the performance achieved just by attending either only the concept or the context, indicating that the proposed dataset require methods to recognize and compose the new concept with the queried context to achieve good results. We compare three state-of-the-art methods on the proposed personalized retrieval task. As baseline, we report also the performance achieved by using a discriminative or rich textual description of the concept. We report performance on queries that contain a chimeric concept and queries that contain common concepts. We see that all methods achieve lower performance when retrieving chimeras in context. To understand the reasons of failure, we measured the recognition score of the concept and of the context in the ranked images, and observed that personalization methods achieve equal or better recognition on chimeric with respect to common objects, indicating that while these methods do learn to recognize the visual appearance of the chimeras, they struggle at retrieving them in composition with known contexts. Most benchmarks for personalized text-to-image generation do not provide real image realizations. Therefore, to evaluate the fidelity of a generated image to the concept appearance, they measured its distance with the training images, and to evaluate the fidelity to the context, its distance with the context textual embedding. Differently, we do have a set of real image realizations for each prompt, which are the ground truth images acquired for retrieval. Therefore, we can measure the distance of generated and real images in terms of realism and diversity using the recently proposed density and coverage metrics. We report these metrics separately for prompts that contain chimeric or common concepts, and observe that, for all methods, these are higher on common concepts than on chimeric ones. This is in line with what was observed in recent work that more common objects are also easier to generate, since these methods leverage the pre-trained knowledge about the concept category. We also see that Dreambooth has the best density, while in terms of coverage, there is a smaller gap with textual inversion. This is confirmed by qualitative results that Dreambooth achieves relatively better realism, but there seems to be room for improvement. We hope that this dataset will help improving current personalized vision language methods.